Is there no class today? Why am I the only one? Oh, okay, cool.
Yes. Yeah, everybody's showing up late. We have our actually 2 o'clock, so we're getting started. I'm sorry. You're not late. You're not late. I'm teaching a class before this one, and I have like a 10-minute break in between, and I typically start the recording before 2 o'clock, but I had a student with me, and that's why I just started it. So good. I think we have everybody. Have 4 students here and 2 students online. So we will get started. First thing I want to do is to ask you if you have identified already a place to do your project. We are like 2 weeks away from the proposal. So I got feedback from 2 students, but I'm waiting for the rest of them. So if you don't have a place, haven't identified a location yet, I will encourage you to do that this week. And let me know as soon as possible, because I don't want to have a duplication. So the sooner you let me know, the higher the chances you're gonna get your place stolen. So anybody else? No, nobody. I have Sawasachi and I have Alex. Remember, it doesn't have to be a complicated system. As long as you can identify there's a queue being formed, you can select a system. It could be any of the fast food restaurants on campus or anywhere close where you live. But you have to have some type of access to collect the information. So for those restaurants here, like in the dining halls, you don't necessarily have to ask for permission. If you do, that's great. Maybe they can provide you with some information from their system. But if you are not able to get someone to talk to, you can observe the system from one of the tables and still do the project. Okay, so talking to the manager will be important in case you want to get some additional information. I'm talking on campus, right? Because you're not going to be dealing with the system, interacting with the system. You're just going to be observing. So you can do that from one of the tables. But if you go outside, like for example, if you go to an actual fast food restaurant, like a building, independent building type of thing, they are probably going to ask you what are you doing. Okay, so you're not going to be able to just sit there and not raise any eyebrows. So make sure that if you go outside the university, you go to a place which you are going to be noticed, that they know what you're doing. Okay. And then you get the right, I mean, the permit, or not the permit, but at least they're informed that you're going to be there, so they're not concerned about your presence. Any questions? Good. So let's transition to our next lab. And in this lab, we're going to be using some new modules. We're actually going to go from the elements and blocks to other modules in Arena. We're going to talk also about a little bit about the history of Arena, how we got to this point. And then we're going to do a lab using these new modules. So the lab is going to be simple. I think the challenge for today's lab is to learn to transition from one template that you already know to a newer one. So lab 4, all these things hopefully. We know the difference between an attribute and today we're going to start looking at a variable in our system. Variable is called working process, WIP. And in order for us to keep track of this value, we're going to use a variable. So this is the first time we're going to use a variable in our models. So far, we have been implementing attributes, priority, job type, color, size. All those are attributes in most of the applications that we have implemented are looking at the job type and the arrival time for the entities. So entities, remember, those are the object of interest. So anything that is moving through the facility, if you're using a create block to generate entities or to generate something into the system, those are your entities. Attributes, very important property of an entity. In variable is the information representing some type of characteristic in the system. In variable, when we have a variable, we need to understand that these numbers are going to be changing. When you have an attribute, numbers are going to stay. Like if you assign a 1 to an entity, that 1 is going to stay. It's not going to change. With a variable, we have numbers that are moving up and down, like a working process type of thing. Every time an entity enters the system, we're going to increase this number. Every time an entity leaves the system, we're going to decrease this number. So that's why we're going to be using a variable. So every time we start an exercise, remember to save it in a safe location and set up your model to generate the Simon report, and also set up that you have the right number of parameters, the right number of replications, and so on. So a brief history about Arena. Arena started with Simon. So if you're familiar with this software, the original name was Simon Arena, and then coined it Arena later on. But Simon stands for Simulation Modeling and Analysis. This was developed in 1982. So all of you were not born. I was born already, but you guys maybe were not even in there. No, you guys are too young. So you were not born. This was the first simulation language for the PC. Okay, so computers started to become popular, and then this was the first simulation language that was created. So it was focusing on manufacturing capabilities, and the orientation was entities flowing through resources, input and output analyzers, and still this original code serves as the Arena core language. So what have changed with the years, almost 40 years, 40 years actually, is the general graphical interface, but the actual code itself, the routines and the capabilities are based on this simulation modeling and analysis language, which is the core of Arena. So here's a illustration of the evolution, at least until we get to the templates that we're going to learn today. So originally for Arena, you needed to type, like you're seeing here in the instructions. You need to create, you have to enter all these pieces of information if you were to assign. And you have, if you remember, when we were working in our models, we have a model frame and an experimental frame. This is the same thing. We have a model frame on the left, and we have an experimental frame on the right. So the code, and if you can still get this code from Arena, I can show you how to do that later. After you complete your building your model, you can request to show this code, and you will have access to all the lines in your code. So from there, we transition into blocks and elements, and then from there, we transition into these new templates. And I think now we have some newer templates, so we will get those at some point. But we are going through this evolution. Newer doesn't necessarily mean that it's better. Okay, so that's why I teach you the elements and blocks. If you can see in this picture, these two are blocks. They're representing the same thing, but you see that instead of using 1, 2, 3, 7 blocks, in this one we only have 4. So with the modifications, actualization of the software, we are basically limiting or combining some of these blocks together, which in part make it easier for the user to build the models, but at the same time is subtracting flexibility for the modeler, because now you have less flexibility in terms of what you can do or not with your model. So again, benefits and cons. So the Arena simulation system is a powerful simulation environment. We have modeling object templates called modules and transactions that move among them, as a visual front end, and is built around the Simon block-oriented language construct and other facilities. So we're going to be starting using these new Arena modules. There are different, there's 3 types: basic process, advanced process, and advanced transfer. So those are the new modules, and these are based on the ones that you already learned. So in my experience, practical experience, I had to build a very complicated model. I will start with these modules, but then when I get to a piece of the logic in which I know I need more detail, more flexibility, I will open the blocks and elements, and I will find those blocks that are no longer available in these modules, and you can combine them. You can use blocks and elements in combination with these modules, and it will work. So you still have that flexibility on combining these templates. So these are the new modules that we're going to be using. We start with the basic process. You see the create, the dispose are there. We have, instead of a branch, we have a decide block. We have the assign. For the statistics, we used to have multiple blocks for these stats, outputs, tallies. Now we only have a record. Okay, so that's another change. Here's some other advanced process and the advanced transfer. So now I'm going to show you the difference or the updates. Basically, you start with the create block. Now you still have a create block, but the window is different. Now you have some already menus that you can use, so you don't have to type. And it tells you clearly what you need to do. For resources, remember that we have a seize, delay, release combination to model a resource. We still have that. We have the seize, delay, release available for Arena. But we also have this block that is called process that allows you to model different combinations of seize, delay, release logic. So you can use a process just to model a seize. You can use a process just to model a delay. You can use a process to model a release, or you can use a process to do all 3 together: seize, delay, release. So if you see here in the action button, in this particular case, I'm using all of them, seize, delay, release, into a single block. So if I want to add a machine to my model, I can just do it with a single block, and then call the action seize, delay, release. So that's about it. For the assign of the attributes, Um, remember that you were using the attributes, elements, and the assign block. So the assign will allow you to assign attributes to the entities. Now we still have an assign block, okay, which is asking you whether you're going to use an attribute or a variable. And you will see that in a minute. So this block is now making sure that you know what you're doing. I think that was a common mistake. People trying to use variables when they were trying to use attributes or using attributes instead of variables, so confusion. So now that the assign is asking you, are you going to model an attribute or are you going to model a variable? So you see a difference, variable, attribute. For the branch block, these were for decision making. Now we have a decide block that is asking you what type of decision you want to make. So it's a two-way by chance, a two-way by condition, or n-way by chance and n-way by condition. So you choose between these options. And then if you select a two-way by condition, you will get a set of questions to complete. You do a two-way by chance, for example, you will get a percentage true, and then the rest will go through the other branch. If you do an n-way by chance, then you're going to get a multiple options to complete. For the statistics, again, as I mentioned already, we have all these separate blocks and elements, tallies, encounters. For now, we have the record block. It could be used for both counter or a tally. You will specify the type of record block that you're going to use here with the type. And you can also check here if you want to record that into sets. Like if you remember when we wanted to do separated the cycle times by part type, we needed to use a set, build a set, and then call the set. We can do that automatically here by recording to set, and then it will ask you by how you want to split the entities. You can tell, okay, by attribute, and that's it. So here's the sets. We can also define sets here. Instead of using a block, we can separate. We have these modules that look like these spreadsheets, or yes, look like a spreadsheet, these tables. Those are used to define the properties of the set, properties of resource, and so on. And then the dstats are managed in this module that is called statistics. And for multiple replications, we used to have the output. Now we're going to use the dstats, the statistic module to manage the output report. And I'm going to show you how to do that. Okay, so enough talking. Now let's look at the practical implementation of this example. This is an example that you already worked on. We are just going to build it using these new modules today. So we have these interarrival times. We have these parts coming into the system. We're going to split them, and then we're going to process them. And then we're going to record the statistics for 10 experiments. What is the average cycle time? What is the average utilization? What is the average number of parts completed? And what is the average number of parts in the system? So that last question is asking you for the working process. Average number of parts in the system. So let's open Arena. Yes.
Getting the last two. Getting the last two.
Yes.
Can I show you now?
Well, we will have to wait until the end. Yeah. Yeah. So if it is about this, we can.
It's like, for every application, customer lead is like 43, 30, 37 data. When we average, take an average, it is like 13.8. Like, this kind of problem. It should be like 35 around.
So when you run, let's say you run 10 replications.
Let's application. The
Yeah.
minimum customer lead is like 30, and the maximum is like 40. So the average will be around like this. Finally, average is, but it came like 13.8. Is it a problem with our model or it can be happen?
Okay, so you are saying that you get a minimum and a maximum, and then the average is outside those bounds? Oh,
No, 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 I'm not.
In this case, I'm talking that answer is like fraction. The person shouldn't the fraction.
oh, the number of parts shouldn't be a fraction? Comment, yeah.
Contact, you know, we can like that. So the customer leave is like 40. Is like 1 second 39 data. So when you say when you take an average, it's 13.885. So the thing is like, is it a problem with model? Like here is the customer leave.
And you had to look
based
at
on-
every single observation. Can you
Yeah.
open the report again?
nothing is below 30. So how it's like 13? You can see minimum is 9.5.
Average number of customer lead.
Every time we can count that. I think is it
Yeah, there should be something wrong.
Yeah,
You
wrong.
lose 37.
37?
So you're doing the NR for counter?
Yep.
Can I see the implementation?
Yep, sure. Paste it. Sorry. And see customer lead.
Average customer lead. Okay, show me the report. The report, yes. But that's not this, oh, that's not the same name.
Because I have to in the output I made
Okay.
gives customer lead. Here you can see. I think so it's a problem with
So you're using NC and then,
instead, and then here I use a name, that name will become here. Then there is another name for the print. Now I mentioned.
so NC is for, yes, I see. Okay, so let's talk about that
Yeah.
at the end of the lecture. Yeah, that's. Okay, so let's go back to this. We're gonna use Arena. Okay, so we are gonna be looking at a new template. The template that we're gonna use today. So this one. I have that one already. So you have to go into what they call all Arena templates. And we're gonna use the basic process. And the advanced process. Okay, so in this one, we don't have to represent or differentiate between the experimental frame and the model frame, because those that separation is already being made by the template. So if you're going to be using the blocks, the yellow blocks, those are used to set up the model frame. And then the experimental frame will be developed using those tables that you see in blue and white with the lines in gray. Those are going to be used to define your experimental frame. Some of these things are going to be defined automatically. So let's start working on this. So this is a create. And we're going to be creating entities. They're going to be arriving using an exponential distribution. So when I double click here, my create block has many options, but now I don't have to type my distribution. This is something that is going to show out the exponential as default. If you're going to use a schedule, we can define a schedule for the arrival. So let's say the first hour you want to have 10 arrivals, second hour I want to have 25. Those can be defined. We're going to look with those. We're going to work with those later this semester. Constant means that the number of people will be arriving every 2 minutes, every 3 minutes. So it's not based on a probability distribution. Or you can use an expression. And when you click on the expression, that's going to open the rest of the probabilities. So you can choose, let's say, the triangular, and it will say in minutes. And then you can complete the expression by including the information for that distribution. The minimum, the mode, and the max. Or if you use the uniform, you have to include the minimum and the maximum. But in our case, we are going to be using the exponential with 4.4 as the average. These are in minutes, and the entities per arrival are 1. And the other thing you can do with these new blocks is you can change the name of the block. Like if you want to specify this create block is for parts, you can just say parts. Arrivals, and that will change the name of the block. Oh, yes. So you say here? Yeah, so I'm not saying that you can, I mean, that's my bad. Since this is a name, it doesn't matter. It's not part of the code. You're just changing the name of the block. So that is not gonna impact your code. So you can use space, you can use capital letters, doesn't matter. But for the code, I will prefer to continue using the same strategy that we've been using. So this is just for the name. I'll just put this back as create 1. Okay, so we are creating entities. Let me save this. And now we are going to assign some properties to our model. Since we are collecting the arrival time. I'm gonna assign, so I'm using the assign block. You see the assign, the assignments is empty right now, so I'm gonna add an assignment. And this assignment is gonna ask me if I'm gonna use an attribute, a variable array, variable array 2D. If I click here, you'll see number of rows for row 1. What's the value? That's not what we are trying to do. We want to use an attribute, and we're gonna call this arrival time. So here we're gonna assign this attribute to every entity. Every entity that crosses this block is going to be assigned an arrival time, and the value of that attribute is Tina. So let me connect these two. And then we're going to split this into two. We can do this in two ways. We can have an attribute defined that will tell me part type 1, 60% of the total, and part type 2 is 40% using a discrete distribution. Or we can just allow the decide block to do the work for us. So it's going to split this 60-40. So let's do that. We can do a two-way by chance, and then tell the model 60% will go through the true. Let me zoom in. So you see, if you zoom in, you have a corner here with the true, a corner with the false. So if the condition is satisfied, 60%, it will go through the true, and the rest will go through the false. If we do an n by chance, you see we're gonna have a list here in which we can include every percentage, and it's going to create a node for each one of these possibilities. But that's not what we're trying to do. We want to do a two-way by chance. So 60% is true. And then we have two machines. So to model the machines, we used to use the seize delay release. Remember, seize delay release. Those are still available in the advanced process. But today I'm going to show you the logic for the process. So we can choose a process here for the true. If you double click there, you see that you have many options in how you want to use this block. Could be a delay, could be a seize delay, could be a seize delay release, delay release. So for our case, since we are modeling a machine, we want to do the entire logic, the seize delay release. And then if you select that option, then you have to add a name for your resource. So this is machine 1. And then you have this unit to seize and release. So this is basically saying how many units do you need to seize this machine. Typically we have 1, so 1 unit is enough. But if you have any other requirement, you need 2 to seize the machines, you can do that here. And then the distribution is a triangular 3.2, 4.2, 5.2. So we're going to have a triangular, units in minutes. So that's another important difference in Arena or these modules. Now you have to make sure that the units are specified in each one of these blocks. If you choose hours here and then tell the model that the units are minutes, it's not going to change this. You have to make sure that you're using the right units. Minimum is 3.2. Most likely 4.2. Maximum 5.2. And when you click after selecting the logic cease delay release, you will notice that a queue is being formed or created for your process. That automatically happens if you have a cease. If you have a cease delay or cease delay release, you're going to see the queue. So the queue now is not a separate block, is also part of this process. Then we have another process for the other machine. And we are going to connect this. Also select the cease delay release. We're going to call this machine 2.
You don't need to have an experimental box.
You need what?
You don't need to have experimental frame.
No. You'll see where that comes into play in a minute. But you no longer have to define the experimental frame with blocks, correct? And then for the probability distribution, we have 3, 4, and 5. So 3, 4, and 5. Yes. This is not China. Do you select the cease delay release? Yeah. Yeah, you have to choose the cease delay release in order to show up. Triangular in minutes. Make sure that you use the right units. So this is machine number 2. It follows a triangular distribution with a minimum of 3, a value most likely of 4, and maximum of 5. Second queue is 4. And now we want to collect some statistics. So I'm going to have a record. In which I'm going to use to count. So my first record, I'm going to double click there and then click add to define the statistics. The default is count. The increment default is 1. The only thing that we have to do to set up our counter here is to change the name. So this will be parts completed. Okay, and then we click OK. But notice that we can add more statistics to this record. Okay, we don't have to bring another record block. I'm doing the count, number of parts completed. I'm going to define another statistic here. This one will be time interval. Okay, so yes. So we want to collect the time interval, right? And when you select that one, you'll see that under that is going to ask you what is the attribute name that you're using? It will be the arrival time. So this automatically will do the subtraction for you. And we will call this cycle time. Something that we haven't discussed is how to collect the working process. So we are going to do that using a variable. So we're going to start with assigning a value here. So I'm going to add a variable. Remember, variables allow you to change as we run the simulation. And I'm going to call this variable working process, or WIP. And then I'm going to initialize this, or basically I'm going to change the value. It's going to be automatically initialized at 0. But every time an entity crosses this block, I'm going to increase that by 1 unit. The difference between this and a counter is that we are also going to decrease every time an entity leaves the system. So we are going to keep track of how many entities are inside the system at all times. That variable is going to be moving up and down, and we're going to use that to compute the average width. So if we assign here to increase, we have to decrease that when the entities are leaving. So I'm going to call another assign block, and I'm going to put that one at the end. So here I'm going to add a variable. The variable name is the same, WIP. But instead of increasing that by 1, I'm going to subtract that by 1. So when they enter, their working process is increased by 1. When they leave, working process is decreased by 1. And then we can add the dispose. Save, check if you have errors. Let me know if you have any errors. We are not done yet. We have to define the statistics. So something that I want to mention, like for example, if you have machine 1 and you have more than 1, when you click on process 1, you see that this window will show up, right? So it gives you some information about your process block for both of them. But if you want to get additional information about your resources, you can come here to this resource table, and it shows you the information that was in the resource elements before. So if you have fixed capacity and you want to increase that by 1 or 2 or 3, just go here to this resource module and you can increase the capacity. If you go to variable here, you will see the definition of your variable, WIP. For the attributes too, the arrival time. And for the queues, you'll see the information about your queues. You have two queues, first in, first out, both of them. So in the same way, we can go to the advanced process and define our statistics. So in the advanced process, there's a module that is called statistic. Please click on that one. And we're going to start defining some of the statistics for our model. First of all, I want to define I think I need to collect the utilization or not. Yes, machine one utilization. So I'm going to start defining that one. You have to remember that the utilization is time persistent. So when you define that statistic, you have to make sure that you select is time persistent. And then it's going to ask you for an expression. When you see that yellow color, that means that you have to complete that piece. If not, you're going to get an error. So the expression for the resource is NR machine 1. And then for the label, I'm going to call this machine 1 utilization. Okay, so this is for the utilization. The good thing about this is that you can keep adding. The next one, I also want to collect the average number of entities in the system. That's also time persistent. And this is a variable. Okay, so I'm going to keep track of that variable. And the only thing I have to do is to call the variable working process. WIP is the name of the variable. And the report label that I'm going to use is number in system. Okay, so those define my time persistent statistics. Now I have to generate my output report. So I have here 4 questions. When I find my output, and I'm going to start with my counter, parts completed. So this is NC parts completed. And this is average parts completed. Oops, there's a typo here. Parts completed. We have another output for cycle time. So this is a tally. So we do TAVG, cycle time. And this is average cycle time. And then if you remember to define the output for a dstat, we have to use the name of the time persistent statistic label. So in this case, machine utilization. So this is dstat, I'm sorry, DAVG. The name of the label for machine one. And this is DAVG machine utilization. And one more. We have our last output for the fourth question. We have a DAVG for the numbering system. So this is DAVG numbering system. And this is AVG numbering system. So those are the four answers to the questions. Those are the four outputs. So very clean. We define all the report using the statistic module. And I can go to the run setup. Let me check my model first. Say no errors. Once you get all the information in, check if you have any errors. No errors? You can go to the setup, run control, reports. You can put the assignment summary report as the option. Project parameters, you can uncheck everything and then hit apply. Replication, we're gonna run 10 replications for 8 hours. And the base time units are minutes. Then click apply. Let's see. If you don't want to see the animation, you can click here. So it looks like our machine utilization is about 58%. average number in system 1.39, average parts completed 1100. I'm sorry, 111. The average cycle time is about 6 minutes. Were those the numbers you got? Good. Yeah, so that shows you the transition between this new or old template of blocks elements to these newer template for basic process, advanced process, and so on. So again, there's benefits and cons of using these two different modules, and knowing both gives you some advantage depending on what you want to model. Good thing about this one is that makes animation more simple. Like for example, if you go to basic process and you click entity, basic process entity, you can choose what you want to use to model or represent your entities. So you want to use a telephone, a truck, a van, woman, a Red Bull, a person, a man, a letter, green page. Let's say we use this package. You run this, you see, I'm sorry, I need to click here. If you run this, it's too fast, super fast. Had to slow down. So if you want to see the animation, you can go to the run control, setup, run speed here. The animation speed you can change. Like if you add more zeros after the decimal place, and then click apply. Oh, sorry, too big of a number. Where's the animation? There you go. So now you can see the different animation going through the model. You can see the cues getting formed. We can take that out from there. Like if you want to build you can bring the cues outside. And then you can also represent the resource. Identifier, machine one, title, BC. Here. Do the same thing for the other one. So machine two. Let's see if we can use another picture. Maybe this one. Title. see. Okay. So when you run this now, you see how the resources are getting queued, and again, the animation part of Arena is not as good as Simio, but it allows you to build some basic animation. It depends on how much time you have to work with that, but you can bring your own pictures to the system and use them as part of your animation and so on. You also have the capability of do 3D modeling like Simio, but that's more is more advanced, requires more level programming that is outside the material for this class. Any questions? So were you able the results? Yes. Were you able to find out what was wrong with your statistic for the previous model? Or not?
Mine,
Is it
The answer is
yours is different?
yeah. Like
How much?
0.57.
0.117?
0.57.
Okay.
And the numbering system is 1.6. And the parts complete is 160.
So are you using 8 hours as your replication time and 10 replications?
$, same, another. Computer,
Supposed to be the same. Are yours different too? You got this? Okay. Yeah, there should be some small difference. Are you sure you got the same answer? Okay. I've seen some weird behavior, so I'm gonna trust you that you have the model. Okay. So do you want to double check your code, Saha, with check the create expo 4.4 minutes? The assign WIP variable. The design block, you have 60%. Process, you have minutes, triangular 3.2, 4.2, 5.2. For the second process, you have chain 2, 3, 4, 5. Then the rest should be the same. Record. Can you bring? Let me see. Can you open this one? Do you have the same order, the variable first and then the attribute next? Yeah. Yeah, I mean, it looks the same. So maybe you're getting a different random number generator. I don't know. Yeah. Are you using
It
next?
might be a different run time too, for the run length could be different or something.
It's using 8 hours too. Right?
Oh, okay, okay.
Yeah. So run, setup, control. Eight hours, app applications. Yeah. Yeah, I would not worry since the numbers are close. It could be that you're using a different random number generator. Uh, One thing I will do is I can post this and you can open yours and see how are they different. I don't see any difference. Okay, questions? You still have that problem with the report? Ah, you found the solution?
What happened, actually, I use NC here. These that it shouldn't be here.
Ah, it should be an output.
That's the problem.
Okay, got it. Okay, so if there's no questions, then I'll stop here. You have a new lab for next week. Make sure that you start working on that and let me know if you have questions. I'll see you on Wednesday.